back. And so I've written down here the first law of thermodynamics says the energy you start with has to equal the energy that you end with, and that's called conservation of energy. Now we're going to talk about the second law of thermodynamics. So when a system operates, it must generate heat. It has no choice. Some of the energy of a system must be turned into heat whenever that system operates. And then that heat escapes into the surroundings. So in any physical system, energy must always be wasted. Now the energy is still there. So if you were to take the energy left over in the system and you were to add it to the energy that escaped, it would still equal the energy you started with. So notice that the first law of thermodynamics is being obeyed in the second law of thermodynamics. But the second law of thermodynamics is going to say that some of the energy in your system is going to be converted into heat and is going to escape. Now it doesn't say how much, because that's the whole purpose of engineering. So engineers are always trying to develop a better engine for a car, one that produces less heat. And so it's still going to obey the first law of thermodynamics, and it's still going to obey the second law, but if they engineer it correctly, they can reduce the amount of heat that it's going to dissipate, which means it's a more efficient engine. Okay, so a second way of thinking about the second law of thermodynamics is through the use of entropy. So entropy is going to be given by the letter S, and it's going to be a measure of the disorganization of the system. So the more disorganized a system becomes, the greater its entropy is going to be. So I want you to think about your bedroom. So what does your bedroom look like after you've cleaned it? I assume that you clean your bedroom. So after your bedroom has been cleaned, everything has been put back on its shelf and everything looks nice. That's a low state of entropy. Okay, but then what happens? Well, the clothes get scattered on the floor, and papers and things get off the bookshelf, and so it becomes more disorganized. So the entropy of your room increases. And so the second law of thermodynamics says the entropy of the universe must always increase. So how is entropy defined? So entropy, the change in entropy of a system, is going to be equal to the amount of heat added to the system or taken out of the system, and then divided by the temperature of the system. So this is how we actually calculate entropy. Now notice the change in entropy. So it's not just S, it's the change in S. So the change in the entropy of a system is the amount of heat added to the system or the amount of heat given off by the system and then divided by temperature. But do you remember the sign convention? So that if you add heat to a system, it's positive, which would mean that this is positive. So the entropy of a system increases if you add heat to the system. If, on the other hand, heat comes out of the system, then this would be a negative Q, and then this would be a negative, and so therefore the entropy of the system would decrease. Okay, now this has a kind of a peculiar thing here. Now the entropy of the universe, which must always, always, always increase. That's the second law of thermodynamics. is going to be equal to the entropy of the system plus the entropy of the surroundings. So you've got these two entropies, and they're constantly battling each other. So it's possible for the entropy of the system to go down. But what's going to happen is the entropy of the surroundings is going to have to go up more, so that when you add the two together, you end up with a positive change in the entropy, so the entropy of the universe increases. So the second law of thermodynamics states, while the entropy of a system or the entropy of the surroundings can decrease, the entropy of the universe must always increase. When you add the two numbers together, it always has to be a positive number. So let's take a look at this. When ice freezes, it becomes more ordered. So when it's a liquid, the molecules are moving around. But as you cool it, they become in a nice ordered crystal. So that when ice freezes, it becomes more ordered, so its entropy goes down. Does this disobey the second law of thermodynamics? You might think that it does, but it doesn't. So we're going to see in lesson number 13 that water gives off heat when it freezes. So when you melt ice, you have to put heat into the ice. So if water turns into ice, heat is going to be given off. So this heat that's being given off is going to increase the entropy of the surroundings. The air around the ice is going to be increased more than the ordering of the ice decreases the entropy of the system. And so when you add the two numbers together, you end up with a positive number, which is the entropy change of the universe has increased. And that is the second law of thermodynamics. All right, let's take a break, and when we come back, let's talk about the third law of thermodynamics.